The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Just a quick note before we begin, folks. The next new episode of the .NET Core podcast will be in 2019. This is essentially because I want to take December off and get as far ahead of myself as possible so that if I'm down with illness for a week, I don't have to fall behind, and you guys can have lots of new content on a more regular schedule. Make sure to check your podcatcher several times today. Essentially, I'm going to release multiple episodes. If you're a patron, then you'll receive 3 episodes today. If you are a non-patron, I don't know what the word should be there, but if you are not a patron, you'll receive 2 episodes today. Non-patrons will receive the 3rd episode in January when we restart for the new season. Enjoy the show, folks. Hello everyone and welcome to the .NET Core podcast. The only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Brockman-Taylor, and this is episode 14, Templating in .NET Core. In this episode, I'll cover how you can work with templates for your .NET Core applications, how to create them, and how to share them. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. It used to be that when you wanted to create a new .NET Framework solution, you had 2 choices. Either use one of Visual Studio's templating wizards, or hand-roll your own project using Visual Studio's file options. File new project, file new file, that kind of thing. And that worked really well when you were building a greenfield project with no pre-existing code or solution template that you wanted to reuse. You could even download new templates for Visual Studio's wizard, but they had to be installed on a per-user, per-computer basis. If multiple users had access to the same development machine, you'd have to install it for each user. This wasn't optimal, but it was the way things were done for years. Some folks even created applications which would scaffold an entire solution for you, based on some input parameters, but these were generally slow and a little clunky to use. If you were brave enough, you could even create a VISX package with your template in it and install it on each machine. The problem with this was the barrier to entry. Learning VisX wasn't the easiest thing to do, and a lot of VisXs were very much based on other VisXs. I know that my own VisX packages are all heavily based on the ones created by Mads Christensen, for example. Then along came .NET Core. Anyone who's read my blog, A Journey in .NET Core, check the show notes for a link, since its inception, will know that one of the early ways of scaffolding applications was to use a Yeoman-based application. This was great, and it worked swimmingly, but it did require Node.js, which I guess is an essential part of the web dev stack these days anyway, and this was a little slow to get up and running. And that's where the .NET Core templating system comes in. .NET New 3. When version 1.0.1 of the .NET Core SDK was released, Microsoft added support for the templating system. This was originally called .NET New 3 and allowed you to create templates for solutions by adding a single file, that's the template.json, to the solution and running a single command. As a side note, each time you've used the .NET New CLI command or used the File New wizard in Visual Studio to create a .NET Core application, you've used .NET New 3 and haven't realized it. Not only that, but you could then upload these templates to a NuGet feed and everyone with the .NET Core SDK could pull them down and consume them. I've written about the templating engine before and you can find a link to that article in the show notes. The absolute magic, and we'll get on to how this works later in the episode, is that it will do namespace renaming and conditional code inclusion for you. Let's have a really quick example using one of the built-in templates. If you open up a terminal and type in .NET space new space console space -- name space my console app, check the show notes for all the code listings. The .NET Core SDK will scaffold an entire codebase for you based on the global console template, and it will ensure that all namespaces start with my console app. That's pretty cool, right? Now imagine that you want to start an MVC application. Well, entering .NET space new space MVC space -- name space nerd dinner space -- auth space individual, again, check the show notes because you're not going to want to hear me say it again, will scaffold an MVC web application using individual auth. Hopefully you can see just how useful this can get. As Dave Rail said on the next episode, the tooling can get out of your way and let you build applications the way that works for you. Custom templates. But how do you create your own templates? Turns out it's really simple. Again, I've written about creating your own templates before, so check the article out for a deeper dive and there will be a link in the show notes. Essentially, you create an entire code base first. This could be a console app, an MVC app, a Blazor app, a web API app, or a combination of those. You can also use whatever architecture you want. N-tier, Onion, whatever. The important thing is to have a working application, but it must be a skeleton application, i.e. it should have no core business logic or customizations added at all. Then you need to create a folder at the top level or root of your codebase called .template.config. This can prove a little tricky in Windows, but should be doable in either Explorer or the command line or PowerShell. Once you've done that, you then need to create a file within that directory called template.json. The contents of this file can range from incredibly simple to ridiculously complex, depending on what you want the template to do. One of the simplest template.json files will have the following key value pairs. It'll have an author, which takes a string and represents the name of the author of the template. It will have classifications, which is an array of strings, which represents the types of apps you can build with the template. So this might be console, MVC, web API, Blazor. It'll have a name, which is the name of the template. Identity, which represents the namespace for the template. And this is the value which is replaced when you supply the -- name tag. And the short name. This is a string and is a CLI reference name. Some of the examples, if you've used the CLI, are Web API, MVC, and Console. All of this information is used by the .NET Core CLI to display information about the template and to provide namespace renaming at creation time. Command line switches like --auth in our MVC example earlier can be added by including a section called symbols. This is an array of objects. Each has the following values. Type, which is a string and will usually be set to parameter. Data type, which is a string representing that parameter's type, so boolean, integer, etc. Default value, which takes a string, which represents the default value of the symbol if the user does not provide one, or even if they don't use it. And description, which takes a string and describes what the symbol does. If you want to see an example of one of my open source templates, you can find it in the show notes. I'm not going to sit here and read JSON out to you because you don't want to hear me read JSON. But check the show notes for a lump of JSON and a link to one of my open source templates where you can find that JSON. Installing templates. It's all well and good being able to create templates, but how do you install them? Once the template is working, it can be built into a NuGet package and placed either in the public NuGet feed or on a private MyGet-based feed. Once that's done, you can install the template on any machine with access to that feed by issuing the following command. Again, this is the CLI, so check the show notes if you can't understand what I'm saying or if you don't want to hear me say it. .NET --new --install the name of the template. As long as that operation completes successfully, you'll have the template installed, and you can confirm this by running .NET --new --list. You can even install the template directly from the codebase that you're building up. This can be a great way of testing that the template that you're building is correct. To do this, you just have to run the following command from the root of your template source code. .NET --new --install --. This will use the template.json file found within the template.config directory to install your template locally. Uninstalling a template, depending on how you've installed it, can be a little tricky. To uninstall a template that you've installed from NuGet, use the install command again, but swap the --install for --uninstall. So our earlier example would be .NET --new --uninstall the name of the template. Whereas if you've installed the template the other way, i.e. .NET new install . I found that the only surefire way to uninstall it is to swap the --install for --uninstall and swap the dot for the full absolute path of the root to the template. So this might be .NET new --uninstall /code/mytemplate/. For a real-world example of installing and uninstalling templates, see the commands file found in my Onion Arch repo on GitHub. Again, check the show notes, there's a link. Wrapping up. In this episode, we looked at what .NET New 3 is, how to create templates for the .NET Core CLI, and how to share them. Remember to check the show notes for a link to the full transcription of this episode, which is available at .NETCore.show. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks.